By this time, it's probably getting repetitive, but step 3 of a hypothesis test is to go ahead and calculate our test statistic. When we go to calculate our test statistic, we need to go ahead and calculate SC first. And with a hypothesis test of two means, our formula is the square root, S1 squared over N1, plus S2 squared over N2. After we calculate SE, the next thing we need to calculate is our t-score, because we're dealing with means. Our t-score is always our observed minus our expected divided by our standard deviation. And specifically, remember, it's an estimate, it's not an actual standard deviation. In this case, our observed value is the actual difference that happened. So that'll be x1 bar minus x2 bar. Our expected is what we expect the difference to be. Remember, our null hypothesis was mu1 equals mu2. Well, if we're assuming that the population means are actually equal, then the difference between them would be 0, which is why we have minus 0 there. We divide by our standard deviation estimate, which is SE. And notice that because I'm subtracting off 0 there, well, 0 doesn't actually matter. So I'm going to go ahead and erase it. And that'll be my t-score. After I do step 3, I'm on to step 4. Step 4 for every hypothesis test is always going to be my p-value. And remember, when I'm using a t-table, what I'll do is I don't worry about drawing my bell curve or anything. I go ahead and I find my degrees of freedom row on my make-believe t-table here. I trace that across. In my make-believe row here, I'd go ahead and find the two t-scores that are closest to mine. So let's say there's one here and one here. Once I find those, I trace it up to the top. And whatever this value here is and whatever that value there is, I say my p-value is in between that one and that one. Now the only difference for this, the only time this would be weird, is once again if I have a not equal to. And if I have a not equal to, I go ahead and we just double those two entails. Our final step for our hypothesis test is step 5. And as always, step 5 is going to be my conclusion step. So moving all of this up here, when I go to try and reach my conclusion, I always compare my p-value to my significance level, which is 0.05 for us. If my p-value is greater than 0.05, I will fail to reject. H0, which means there is not enough evidence to suggest whatever I'm trying to prove. And on the other hand, if my p-value is less than 0.05, I reject H0. And that means there is enough evidence to suggest whatever I'm trying to prove. Notice by this point, step 5 has gotten really, really repetitive, right? We always compare to 0.05, that's always our significance level. Greater, fail to reject, less than, we reject. This is going to be true for all of the tests we do. So far we've had T's and Z's with means and proportions. We're actually going to get a couple more now pretty soon here. So this has taken us through steps 3 with our calculation, step 4 with our p-value, and step 5 for our conclusion. Once again, with two means.